departments. These institutions became incubators for the next generation of innovators who were eager to push the boundaries of what computers could do. One of the most notable institutions during this period was Stanford University, where a young engineer named Douglas Engelbart was making waves. Engelbart believed computers could augment human intelligence, and in 1968, he demonstrated his vision in what became known as the mother of all demos. During this landmark presentation, Engelbart introduced the world to the mouse, hypertext, and video conferencing, technologies that would become ubiquitous in the coming decades. Around the same time at MIT, another visionary named John McCarthy was exploring the possibilities of artificial intelligence. McCarthy coined the term artificial intelligence in 1956 and became one of the field's leading figures. His work on the Lisp programming language would lay the foundation for AI research, and his ideas continue to influence the field to this day. Meanwhile, IBM, the behemoth of the computing industry, was developing mainframe computers that would dominate the business world for decades. These machines, like the IBM System/360, were powerful but expensive, accessible only to large corporations and government agencies. However, the seeds of the personal computing revolution were already being sown. Chapter 3. The Dawn of Personal Computing. The 1970s marked a pivotal moment in the history of American computer science. It was during this decade that computers began to move from the domain of large institutions to the hands of individuals. This shift was driven by a new generation of entrepreneurs and visionaries who saw the potential for computers to transform everyday life. One of the most iconic figures of this era was Steve Jobs, co-founder of Apple Inc. Along with Steve Wozniak, Jobs set out to create a personal computer that was affordable, user-friendly, and accessible to the average person. The result was the Apple II, released in 1977. The Apple II became a huge success, popularizing the idea of a computer as a household appliance. At the same time, Bill Gates and Paul Allen were making waves with their software company, Microsoft. Their big break came when they developed an operating system for IBM's first personal computer, the IBM PC. This operating system, MS-DOS, would become the foundation for Microsoft's dominance in the software industry. These developments marked the beginning of the personal computing revolution, a period of rapid growth and innovation that would forever change the world. Suddenly, computers were no longer the exclusive domain of scientists and engineers. They were tools that could be used by anyone, for everything from word processing to gaming. Chapter 4. The Internet Age. As personal computers became more widespread, the next major breakthrough in American computer science was already on the horizon: the Internet. Originally developed by the U.S. Department of Defense as a way to connect different research institutions, the Internet quickly grew into a global network that connected people and computers around the world. The invention of the World Wide Web by British computer scientist Tim Berners-Lee in 1989, combined with the creation of web browsers like Mosaic and Netscape, made the Internet accessible to the general public. Suddenly, information that was once locked away in libraries or academic journals was available at the click of a button. Silicon Valley, the epicenter of the tech industry, became a hotbed of innovation. Companies like Yahoo, Amazon, and Google emerged, creating new ways to search, shop, and communicate online. Google, in particular, revolutionized the way people accessed information, with its powerful search algorithms becoming a gateway to the world's knowledge. As the Internet grew, so did the potential for new forms of communication and social interaction. In 2004, a young Harvard student named Mark Zuckerberg launched Facebook, a social networking site that would go on to reshape the way people connect with each other. Social media, along with other innovations like streaming services and cloud computing, transformed the Internet from a tool for research and communication into a platform for entertainment, commerce, and social interaction. Chapter 5. The Era of AI and Quantum Computing. As the 21st century progressed, American computer science continued to evolve at a rapid pace. One of the most significant areas of development has been artificial intelligence, AI. Thanks to advances in machine learning, natural language processing, and robotics, AI has moved from the realm of science fiction to reality. Companies like Google, Microsoft, and IBM have led the charge in developing AI technologies. Google's DeepMind achieved a major breakthrough in 2016 when its AI system, AlphaGo, defeated the world champion in the complex board game Go, a feat previously thought to be decades away. AI is now being used in a wide range of applications, from self-driving cars to virtual assistants like Apple's Siri and Amazon's Alexa. The possibilities seem endless, but they also raise important ethical questions about the role of AI in society, such as how to ensure that these systems are used responsibly and fairly. Another frontier that American computer scientists are exploring is quantum computing. Unlike classical computers, which use bits to represent information as either 0 or 1, quantum computers use quantum bits or qubits, which can represent both 0 and 1 simultaneously. This allows quantum computers to solve certain types of problems much faster than classical computers. Although quantum computing is still in its early stages, companies like IBM and Google are making significant strides in developing quantum systems. If these efforts succeed, quantum computers could revolutionize fields like cryptography, material science, and drug discovery. Chapter 6. The Future. As we look to the future, the field of computer science continues to be one of the most dynamic and rapidly evolving areas of research and development. New technologies like blockchain, virtual reality, and the Internet of Things are opening up new possibilities for innovation and growth. At the same time, computer science is becoming increasingly interdisciplinary, with applications in fields like biology, medicine, and environmental science. Researchers are using computer models to simulate everything from the behavior of cells to the impacts of climate change, demonstrating the power of computing to solve some of the world's most pressing challenges. But with these advances come new challenges. Issues like cybersecurity, data privacy, and the ethical implications of AI will require careful consideration as we move forward. The future of American computer science will be shaped not only by technological progress, but also by the decisions we make about how to use that technology. As we stand on the brink of a new era, it's clear that the story of American computer science is far from over. From the early dreams of Vannevar Bush to the cutting-edge research of today, it has been a journey of imagination, innovation, and discovery. And as long as there are problems to solve and challenges to overcome, that journey will continue.